Alright, this is a lesson on Chapter 5, Lesson 3. This is about properties of operations. It's going to be kind of a quick review. The commutative property states that you can add or multiply in any order that you want. So you can move things around. For example, 7 times 3 is the math fact for 21. Well, 3 times 7 is also 21. 4 plus 9 is the same as 9 plus 4. So in other words, order does not matter in addition and multiplication. That's not true for subtraction and division, but the commutative property of addition, the commutative property of multiplication says things can travel in the problem if it's addition or multiplication. The associative property. The associative property starts, well, I think about the root word being associates, which is your group. The associative property states in addition and multiplication, the grouping does not matter. So, if you notice this problem here, I have 5 plus a group of 15 plus 8. That is the same thing as if I were to not change the order, 5, 15, 8, 5, 15, 8, but now I put 15 and 5 in a group together and leave 8 on the outside. Doesn't really change it. Same thing here, I have 4 times 5 times 9, or 5 times 9 are in a group. Now I have 4 times 5 in a group times 9. You're going to get the exact same answer. Once again, we didn't change the order, we changed the grouping. And that works for both addition and multiplication as well. It's called the associative property. The grouping can change. The first one, things can travel if it's additional multiplication. In associative, the grouping can change if it's multiplication or addition. Distributive property, I'm going to leave that one for another day. We'll have an entire lesson on distributive property, but I'll give you the preview. Distributive property means if you're distributing something to an entire group, everybody in the group gets some. All right. Next one is the identity property of addition, and that is anything plus 0 equals itself. So 7 plus 0 equals 7. 9 plus 0 equals 9. Chicken plus 0 equals chicken. Because that plus 0, that's still its identity. It does not change what it is. Another one is identity of multiplication. Anything times 1 is itself. In addition, anything plus 0 is itself. In multiplication, anything times 1 is itself. So 7 times 1 is still 7. 9 times 1 is still 9. And chicken times 1 is still chicken. We use that all the time when we're doing things like common denominator. So we have to change that to an equivalent fraction by taking it times 1. It can change the way it looks, just like our DNA. We can change the way we look, but it doesn't change our DNA. I can have a different haircut, but it doesn't change my DNA. So if I had like 3/4 and I took it times 2 over 2, isn't 2 over 2 1? So then when I take it times 2 over 2 and I get 6 over 8, 6/8 is equivalent to 3/4 because its DNA did not change. It might change the way it looks, but it's still the same amount. We have the inverse of addition. Inverse of addition, that might remind you of additive inverse. That's because anything plus its opposite, which is also called the additive inverse, is 0. That's a good way to get back to 0. So then, if we're back to a 0, plus 0 is its identity. That will go together with that when we're doing algebraic equations. So, negative 8 plus its opposite of 8 is 0. H plus its opposite is 0. 18 plus its opposite is 0. Inverse of multiplication. We've used this term before, multiplicative inverse. That means anything times its reciprocal, or multiplicative inverse, will get you back to 1. Why would I want to be back at 1? Because in multiplication, anything times 1 is still itself. That's its identity. And then finally, the 0 property. I think your book calls it a little bit something different this year. The multiplicative property of 0, I believe. But anything times 0 is 0. 7 times 0 is 0. F times 0 is 0. Chicken times 0 is, you don't have any chickens, you have 0. Alright, so let's do the guided practice off page 370, I believe I said. Let's do just a couple of them. It's wanting you to see the property. What property is this? Anything times 0 is 0. That's called that multiplicative property of 0, or the 0 property. Anything plus 0 is itself. It didn't change. Its DNA is still exactly the same. That is its identity. The identity property of addition. Number 3 says, subtraction of whole numbers is associative. Do you agree? Well, let's try it. 2 minus 5 minus 7. 2 minus 5 minus 7. Notice all I didn't change the order, I changed the grouping. So 5 minus 7 would be, leave change opposite, different sign subtract, sign is larger, negative 2. 2 minus negative 2 is 4. Over here, 2 minus 5 is 3. Negative 3, right? Negative 3 minus 7, leave change opposite, difference or same sign, add, use that same sign. Let me ask you, if one ended up being 4 and one ended up being negative 10, is that associative? And the answer is no, it's not. I just gave you a counter example. I gave you one that proved that it is not the same if I group it differently. All right, next one, simplify. We need to justify each step. 9c plus 8 plus 3c. All right, well, I might want to get these together. Couldn't I switch the order of these, called the commutative property? So the commutative property states that I could leave the 9c there, and I could switch the 3c and the plus 8. Haven't changed the problem. Will still be the same according to the commutative property. Then, couldn't I say that I could, according to the associative, I won't abbreviate that one. According to the associative, I'm going to put the 9c and the 3c together and leave the 8 separate. Now I've got my c's to where I can put them together. If I have 9c and I have 3c, I have 12c and I have 8. Now I have it simplified. I have all of my variable pieces together, all my constant pieces together, simplified, and we're finished.